Now, part B of this question wants us to draw one full cycle of the waveforms with the voltage waveform and the current waveform of what we are expected to see on the oscilloscope. Okay, taking the information from the question, earlier on we have calculated what is the period of one cycle, which is 10 milliseconds. And given that the vertical scale setting is 5 volt per division and the horizontal scale setting is 1 millisecond per division, which means that if I were to expect this waveform to be seen on the oscilloscope, remember we calculated that the peak voltage, peak to peak, or rather the peak voltage was 20 volt, right? Which means that in order to represent this voltage on the vertical scale, we will need the number of division on the vertical scale will be 20 divided by 5, which is 4 division. So to show the whole waveform, which is peak to peak, will be 4 times 2, which is 8 division. That means roughly, if I were to sketch it out, the waveform should reach 20 volt here, so there should be 4 division, 1, 2, 3, 4, and same thing on the other end, 1, 2, 3, 4, right? So the waveform to go in between. But because there is a minus 36 degrees, so the maximum when you reach here will be delayed by something equivalent to, will be delayed, right? That means something like that. Will be delayed due to the minus 36 degree. Whereas on the other hand, the ampere, now remember the ampere cannot be measured directly, so ampere must have, remember there's a factor of 2 ohms there. So the peak voltage, so to speak, so this one will represent as channel 1, and the channel 2 will reflect the current, right? So current I need to multiply and convert it back to voltage equivalent will be 5 times 2, which is 10 volts. In other words, it will have a lower maximum, but because of the plus 30 degree, the waveform will be slightly ahead, right? Slightly ahead will be something like this. The other way around, sorry. So slightly ahead, so this is 30 degrees. So it will go something like that and reach the maximum somewhere there and comes down, right? So the waveform will look something like that. Now, in order to draw this properly, I need to calculate all the division first. For example, so 8 division, 4 division. Whereas for channel 2, right? Let's say this is channel 1. Channel 2, the voltage peak will be only 10 volt. That's 5 ampere times 2 ohm. Whereas the peak to peak is 20. So this is the similar from here will be 2 division, and this is 4 division. Right? Now similarly, for the horizontal division, T is 10 milliseconds. Therefore, the number of division to represent one cycle is because the setting is 1, so it's 10 millisecond divided by 1 millisecond. So I need 10 division to represent the whole cycle.